Today's notes are titled 11-3 Surface Area of Pyramids and Cones. We're going to set up our notes exactly as last time with two examples. We're going to set it up from the bottom, 12 lines, then 10, and whatever's left will be at the top with who am I and definitions on the top. So on the upper left-hand side, I'd like you to write, what am I, what's my name? And we're just going to draw two quick shapes, starting with a square. So I'm drawing it kind of from perspective of the corner, all congruent sides, and then a circle. And I'm going to have both of these come up to a point. So there's my top point right there. And from this top point, I'm going to take it all the way to every corner. This would be called a square pyramid. And this would be a circular pyramid, but it actually goes by another name that it's more known as, otherwise known as a cone, but both are correct. For definitions, there are three words, two that we're going to review, surface area and lateral area, and the new vocabulary word slant height. So what we're going to do is we're going to draw our square pyramid one more time. So we draw our square, and then at our top point we connect that to every vertex. And I'm also going to draw my pyramid as a net. So this is what it would look like if I undid this square pyramid and I laid it flat. So the total surface area would be if I took area 1, area 2, area 3, area 4, and area 5, and I added them together. So the surface area would be area 1 plus area 2 plus area 3 plus area 4 plus area 5. Now the lateral area, and I'm going to draw that as blue, the lateral area is just the area of all of the sides, not including the base. So in this case, the lateral area would have been, and I know I covered it a little bit, but the lateral area would only be area 1, area 2, area 4, and area 5. So it's not including this base. Now the slant height, we're going to have to look at our 3D figure to see that. The slant height is exactly that. It's a height, so it has to be perpendicular, but it's a slant height, so it's a slanted height. So how can you have something be perpendicular but also right? So let me show you the height first. The height of this pyramid comes from the very top point down to the center. That would just be the height. The slant height, though, is a little bit different. The slant height is on one of the faces on the lateral side right there. So the slant height is this green line right there. So it's not on the center of the pyramid, it's on one of the sides of the pyramid. So there are two strategies for finding the surface area, as you know. So if I had my square pyramid, just keeps on coming back, you're going to be an expert at drawing square pyramids. One option is to take that square pyramid, lay it flat, and take all of these areas and add them together, and that would give you your total surface area. The other option is to follow this formula again, and I want you to notice it looks very similar from the one from last class. It says the surface area is the lateral area plus the area of the base. What's different? It's missing that 2 right there. Now you should also note that the lateral area has changed for a pyramid. The lateral area is the perimeter of the base times the lateral height divided by 2. So these are two totally equal options for finding the surface area of a pyramid or a cone. Okay, for example 1, the first thing that you'd need to note is that they're asking us to find the surface area, and this time instead of giving us a prism, they've given us a pyramid, and I can tell that because all of my edges go up to a point and there is only one base. Now to find the surface area, I'm going to use this formula, and that means I'm going to need these 3 steps. First, I'm going to find the lateral area, Then I'm going to find the area of the base, and last I'm going to take these values and plug them in where they belong. Now you need to copy this picture. You definitely need to copy these steps, but this is already in your notes. You can copy it again if you want. Okay, so let's color code our steps. So step 1, let's find the lateral area. So step 1, the lateral area is the perimeter of the base times the lateral height divided by 2. So there are two things I need to find, the perimeter of the base and the lateral height. Now this wasn't well drawn, but I can tell you that this was meant to be shown as a square. So the perimeter would be 24 times 4. So 4 times 4 is 16, 4 times 2 is 8, plus 1 is 96. So far I have 96 times the lateral height divided by 2. I'm missing the lateral height. Now the lateral height is a right angled, it should be right next to a right angle, and it's a line that's perpendicular but on one of the outer faces. So the question is, how do I find the measurement of this lateral height? Now this is a little tricky. I want you to really look at this and see if you can see it here. If I take this piece out right here, do you see what shape I'm outlining? It's a triangle. If I connect it right here, you might be able to see it. I'm actually going to draw it so you can see it. This is the 9 inches. This is the lateral height. What is this measurement right here? Remember, the height goes down from the vertex to the center. That means it should hit it right in between this 24. So it splits this in half, this whole length. Half of that would be 12. So the question is, what is the lateral height? Well, this is a right triangle. So a squared plus b squared equals L squared, or 81 plus 144 is L squared. L squared is 225, which happens to be 15. Now I'm going to spare you the multiplication of 96 times 15, and I'll tell you it's 1,440. Now we still need to cut that in half, and I'm going to bring this down a little bit. Half of that is 720 inches squared. So let's just recap what we just found. The lateral area is the area of these 4 triangles that come up to this point, but it doesn't include the base. And that makes sense that our next step would be to find the area of the base. The area of the base happens to be the area of a square, which I know is a parallelogram, so I'll need to find the base and the height. The base is a square that looks like this, with side length 24. So that means I'd be multiplying 24 times 24, and again I'll spare you. That's 576 inches squared. And that is the area of my base. So we found the area of the 4 triangles at the top. That's my lateral area. I found the area of the base. That's everything. So I'm ready for my very last step, which is the surface area. So step 3, the total surface area is just the lateral area plus the area of the base. So that's 720 plus 576. So I'll do that math over here. That's a 6, a 9, and a 12. 1,296 inches squared is my total surface area. Okay, example 2, I do want you to copy the words. It says, find the surface area of a cone with a slant height of 25 centimeters and a radius of 15 centimeters. Leave in terms of pi. These are the formulas we're going to be using, which have already been copied in your notes. And these are the steps you copied in example 1. If you can copy them again, or you can just reference example 1. Okay, we need to start by actually drawing the picture. So here's what I have. I have a cone. Okay, and it says the radius is 15 centimeters and the the slant height is 25 centimeters. Now we can start with our color coding. Step 1, find the lateral area. The lateral area is the perimeter of the base times the slant height divided by 2. Alright, actually I did not want to draw that line there. Okay, so let's find the perimeter first. The perimeter of the base is this measurement right here. So the perimeter happens to be the measurement around a circle. That's a circumference, which is 2 times pi times the radius. Since they told me I can leave it in terms of pi, I just write 30 pi centimeters. So when I move this around and I plug in my value, I have 30 pi times the lateral height, which, hey, we were lucky. They gave it to me. It's 25 divided by 2. So that's 750 pi divided by 2. And 750 cut in half happens to be 375 pi centimeters squared. And that is my lateral area. Okay, now we're ready for step 2. Step 2 is asking us for capital B, which is the area of the base. The area of the base happens to be a circle, right there. So the area of the circle is pi times radius squared, which is pi times 15 squared. 15 squared is 225 pi centimeters squared. And that is the area of my base. Now, this is the easy part. Last but not least, the surface area. The surface area is just a matter of plugging in all the information we already found, which is the lateral area being added to the area of the base. That's 375 pi plus 225 pi. Well, that's not too bad. 375 and 225. These are like terms because they both have pi's. That's a 10, another 10, and a 6. So that's 600 pi centimeters squared is my total surface area of my cone.